Have you ever wondered how transistors work in a circuit? Well, you're in for a treat. Transistors, the unsung heroes of the electronic universe, are the building blocks of modern technology. From your smartphone to your smart home, these tiny but mighty components are the lifeblood of circuits, controlling the flow of electricity like a traffic cop. This video is your key to unlocking the fascinating world of transistors. So brace yourself for an electrifying journey. Stay tuned to uncover the magic of transistors. Before diving into the workings, let's clarify what a transistor is. A transistor in its simplest form is a switch, but not just any switch. It's a semiconductor device that can amplify or switch electronic signals and electrical power. It's like the linchpin of modern electronics, underpinning the operation of a wide range of devices from radios to computers. Now, the basic structure of a transistor consists of 3 layers of semiconductor material. Picture a sandwich, but instead of bread and filling, you have 2 N-type materials with a P-type in the middle, or vice versa. These layers correspond to the 3 components of a transistor: the emitter, the base, and the collector. The emitter emits the electrons or holes, the base controls the flow, and the collector collects them. These components work together, interacting and reacting to inputs and outputs, making the transistor an integral part of electronic devices. Now that you understand the basic structure of a transistor, let's delve into its operation. So, how does a transistor function within a circuit, you may ask? Well, let's dive right in. Firstly, it's important to know that there are 2 main types of transistors: NPN and PNP. Now, don't let the alphabet soup confuse you. NPN stands for negative, positive, negative, and PNP stands for positive, negative, positive, indicating the configuration of the semiconductor materials they're made from. Now let's understand the working of these transistors. Picture a transistor as having 3 layers, with a base sandwiched between 2 other layers known as the collector and the emitter. The magic happens when a small current is applied at the base. This controls a much larger current flowing between the collector and the emitter. This is where the amplification effect of a transistor comes into play. By controlling a larger current with a smaller one, we can amplify signals. This property is the cornerstone of many electronic devices we use today, from radios to computers. But wait, there's more. Transistors are also used as switches in digital circuits. When a certain voltage is applied to the base, the transistor switches on, allowing current to flow from the collector to the emitter. When that voltage is removed, the transistor switches off, stopping the flow of current. This on-off action is the basis for binary code, the language of computers. So transistors, these tiny components, are capable of both amplifying signals and acting as switches, making them the essential building blocks of modern electronics. They're like the unsung heroes working tirelessly behind the scenes to bring all our favorite gadgets to life. So that's how a transistor works. Fascinating, isn't it? And to think, these microscopic marvels are hidden in plain sight in every electronic device we use. They're a testament to the ingenuity of human innovation, turning the complex language of electrons into the digital age we know and love. Let's recap what we've covered today. We've embarked on a journey into the intricate world of transistors, those microscopic yet powerful components that are the backbone of nearly all electronic devices we use in our daily lives. We started by dissecting the structure of a transistor, revealing that it comprises 3 layers of semiconductor material. These layers, named the emitter, the base, and the collector, work together in harmony to control the flow of electric current. We then dove into the function of a transistor, which acts as a gatekeeper, controlling the flow of electric current through it. This is achieved through a small input current applied at the base, which modulates a larger output current flowing from the collector to the emitter. Furthermore, we explored the 2 primary uses of transistors in circuits. First, as an amplifier, enhancing weak signals into stronger ones, and second, as a switch, turning current on and off in response to an input signal. These functionalities make transistors the unsung heroes of the electronic world, enabling the operation of everything from radios to rocket ships. And there you have it. A simple guide to understanding transistors. Remember to like this video and subscribe to our channel for more enlightening electronics content. Until next time, keep exploring the fascinating world of electronics.